हाँ थिला तो पता पठे देबे और देखि देखि पठे देबे हला what is the aim of the experiment today? Aishwarya Mahapatra.
Ma'am, study of buck converter and boost converter.
Today we will not do that buck converter and boost converter. We will do first the PWM inverter. The next class we will do buck and boost. Okay?
Okay, ma'am.
So, what is an inverter?
It is a device which converts AC to DC to AC.
DC to AC or DC to controllable AC. Okay?
Yes, ma'am. Control.
So in theory, we have not studied inverter, I think, because module 1 is there, only rectifier is there in module 1.
Yes, ma'am. Converter is going on.
Okay. So we'll study about inverter. So inverter converts what? DC to AC. Yes or no? Rectifier, no, inverter is the opposite of rectifier. Yes or no?
Yes, ma'am.
This picture is visible to all?
Yes, ma'am.
So here actually in your syllabus only single phase inverter is there. Yes or no? Single phase voltage source inverter is there. Okay. So we'll study single phase, three phase will not study. Okay. Why it is called as voltage source inverter? There is two types of inverter. One is voltage source inverter VSI, another is CSI, current source inverter. Okay. In the current source inverter, the input is current source. Okay. Here the input is what? Voltage source. Yes or no?
Yes, ma'am.
So we'll study VSI. We'll not study CSI. So VSI, you can see how many switches are there here?
4 switches.
4 switches are there. So S1, S2, S3, S4. So here in between you will connect any load. So let we are connecting R load. Okay. You can connect RL load. Okay. So in the theory we will study. There is a difference between VSI and CSI. You remember, if load changes, the output waveform will not change. For a VSI, V0 waveform is same irrespective of its load. What is the parameter will change? That is the current. Current will be different. Load current will be different for different types of load. Output voltage will be same. Okay. In CSI, output current waveform will be same, but voltage waveform will be different. Buji porcho? This is one difference between VSI and CSI. So here if you change the load, the output voltage waveform will not change. Okay. The output current waveform will change. Understood? VSI माने voltage waveform fix रहेगा. Okay. Current CSI रे current waveform fix रहेगा. Change होगा तो opposite change होगा. बुझी होची तो?
Yes, ma'am.
So here we'll do only we'll plot the V0 waveform. Okay, V0 waveform will plot. So तुम्हें जो भी load नहीं पड़ा, R नहीं पड़ा, RL नहीं पड़ा, because this voltage waveform will be same. Okay, so we'll take R load because we are studying the output waveform. We'll take the R load. Okay, so here your R load is there. Yes or no? Here your R load is there. So tell me how the switches will be on in this circuit. Tell me. Think here there is a resistance. Draw it only. Okay. Tell me how the switches will be on. Let me draw in between. Okay, so this is the load resistance. So load resistance will be connected. Previously source was connected like this or not? In between, in the middle of two arms, source was connected in the rectifier circuit. Do you remember?
Yes, ma'am.
So now you can see load is connected like that. And here source is connected like a load in the rectifier. Yes or no? DC. Okay. So tell me how switches will be on. So tell me, let I want a positive. So in the output, I will have a positive output because it is AC. Then a negative output. Again positive output. Again negative output. Like this I will get or not? Yes or no? होना नहीं रे?
Yes, ma'am.
Yes, ma'am.
So tell me, if I want this type of waveform, my input voltage is VD and this is varying VD to minus VD. The magnitude is varying VD to minus VD. So how I will switch on the switches? How I will turn on the switches? Tell me. अरे कुहा भूलो तो कुहा. I will connect for this switch 1 and switch 2 will be on. Okay. To get a positive output, I will on switch S1 and switch S2. So how the current will flow? It will flow from source, then load, then S2, then it will return. Yes or no? So here
Yes, ma'am.
first step. Second, let I want a negative output. So here current, now it was downward. If downward sila na previous condition mein, it should be
Yes.
upward. Yes or no? So in the next half, this S3 and S4 will be on. So how the current will flow? Tell me. It will start from again here, go to S3, then B, then upward, then like this, then S4, then negative. होना नहीं, बुझियो ना नहीं, नहीं बुझेला नहीं. You can see here the current is upward. Yes or no? Upward or not? So in the output you will get, if you are considering the first one as positive, obviously second one will be negative. In the next half cycle, in the next half, again switch 1, switch 2 will be on. Again S3, S4 will be on. Is it clear or any doubt?
Clear, ma'am.
मैम नेगेटिव वोल्टेज रे करंट डायरेक्शन चेंज होछ तो
हाँ करंट डायरेक्शन क्या चेंज होबनी करंट डायरेक्शन चेंज होछ करंट डायरेक्शन चेंज हेला तो वोल्टेज पोलैरिटी चेंज होबो ना एपटा पॉजिटिव होबो एपटा नेगेटिव होबो ना व्हाट इज V0 ड्रॉप अक्रॉस दिस लोड यस और नो
यस मैम
here it is mentioned positive negative means this is your reference one, so you are for first half cycle you are considering this is as positive, so if you are going from this to this then that means you are getting negative. Yes or no?
यस मैम
Is it clear?
Yes, ma'am.
So here, if because these switches are controllable switches, you will give the get signal, yes or no? So if you will, what is PWM? I will say PWM is pulse width modulation, but manually also you can give the get pulse. Okay, you will give the pulse generator here, you will give the pulse generator here, and same pulse generator if it. Okay, IGBT you can use MOSFET. Okay, yes or no? So do you remember in the gate pulse previously only for 2 degree you are giving the gate pulse when it is SCR? Kete degree gap douthula re? The pulse duration is for 30 to 32, that means 2 degree. Yes or no?
यस मैम
But here, the gate pulse can double jump. If you are taking IGBT and MOSFET, let I am switching on the first gate pulse because both are same. G1 and G2 are same. Yes or no? So if you are using IGBT and MOSFET, if you want to switch on for this much period, you have to give get pulse for that much period. That means continuously you have to keep your switch on. Understood? So if this is my one full cycle, up to this one full cycle or not, and this is half of my full cycle, 360 degree, yes or no?
Yes,
ma'am. So for half of the that is 180 degree. Half of the full cycle means 180 degree. So for 180 degree, G1, G2 will present. And after that, G3, G4 will be present. So if I'll draw the gate pulse, it will look like this, that continuously you have to give the pulse. So this is my gate pulse, G1 and G2 are same, so I'm writing G1 and 2, okay, both G1 and 2. So if this is like this, so next G3 and G4 will be like, first half it will be 0, then next half it will be there, understood? So continuously, if you will give get pulse to G1, so let you are starting from 30 degree, so you will give similarly for 180 degree, you will give the get pulse. Yes or no? Understood? बुझी ना नहीं?
मैम authority
अरे जदि एटा मो 0 रे ऑन करछि, so if I not 0, so for G1 रो get pulse तो केम दबो? 0 to 180, yes or no? अरे जो टाइम रा दउथलो गेट पल्स मन पड़छ ना मन पड़नी?
Yes, ma'am. Yes, ma'am.
इट गोटे थिला ना कि गेट पल्स जो एससीआई रे जोटा दउथलो 30 ରୁ 32 दउथलो ना दउनथलो मन पड़छ?
Yes, ma'am.
Switching points, number of points to switching points कौन थला 0 ରୁ 180 by default तो आको में चेंज करथले कोन 30 ରୁ 32 करथले ना नहीं रे?
yes
So
ma'am.
80 if will start at 0, sorry, if will start at 0, so you have to give the gap 180 degree. बुझेला?
Yes, ma'am.
So for G1, the switching points will be 0, 180 degree. अब G3, G4 रे केते हबो? G1, G2 रे 0 to 180 degree. G3, G4 रे केते हबो?
180 to 360.
180 to 360.
180 to 360. तार माने this is the starting period. 0 degree is the starting angle, but the gap is 180 degree you are giving, because IGBT and MOSFET continuously you have to give the gate pulse. If you remove the gate pulse, that means that switch is off. किंतु जोटा SCR नुह, तो मैं already you have studied the switching device, yes or no, in model 1.
Yes,
So
ma'am.
for IGBT, if gate pulse is present means that is on. If gate pulse is removed means that is off. Same for MOSFET. But that is not same for SCR. Once it is on means it is on. That's why you have only given 2 degree difference. At 30 you are switching on means, or 30 degree means it is on. Yes or no? Till the negative half cycle comes, it is on. Yes or no? But here, बुझियो ना बुझियो नहीं?
आगे हम जज.
So if I want to switch on for 50% of the full cycle, that means 180 degree. So I have to give get pulse for 180 degree. तो मैं यदि चाहूँ जो 30% ऑफ कर देबो को, so you have to give get pulse for 30 degree duration. Okay? Yes or no? So 0 to 30 you will give the get pulse. So continuously get pulse will be present. Clear? So manually you can design this inverter. Okay, you can try that home, but that is not in our lab syllabus. But theory you are studying that in your class. Theory you will study that, so you can try it in PSIM. Okay. So what is PWM? So basic inverter you have understood? Yes or no?
Yes, ma'am.
So I'm going directly to the diagram. Okay. So you can see. So here directly you are not giving gate pulse. To generate the gate pulse, you are using, actually there are different types of PWM methods. Okay, that is also in your theory, single phase FET, single PWM, multiple PWM, and the mainly, majorly or widely used PWM method is sinusoidal PWM. Okay, so the diagram is like this, sinusoidal PWM. So modulation method, you know what is modulation? What is modulation? How many signals are present in a modulation technique? So already you have studied in physics, you have studied amplitude modulation, frequency modulation. Yes or no?
Yes, ma'am.
So tell me how many signals are present. Let it is amplitude modulation. So how many signals are present in amplitude modulation? Viso?
Yes, ma'am.
How many signals are present?
Ma'am, जानी
What do you mean by modulation?
Two signals.
Two signals. Very good, Diksha. Two signals because you are modifying one signal. Yes or no? So what are the signals name? Can you tell, Diksha?
ଗୋଟେ ଇନପୁଟ ଥାଏ ତାପରେ ମାନେ ଆଉଟପୁଟ ଯେମିତି ଦରକାର ଥାଏ ସେଇ ହିସାବରେ ମାନେ ଏସି ଡିସି ଥାଏ ବୋଧେ ସିଗ୍ନାଲ
No, that has some name. The two signal input has some name. Anyone?
ନେମ୍ ଜାଣିନି
Abhishek, Achari?
Ma'am, carrier or envelope?
Yes, carrier and reference. Okay. Envelope it will form, but carrier and what? Reference signal. Yes or no? So similarly, you can see here I have two signals. One is, so first one is this sine wave. Why this is known as sinusoidal PWM? Because the reference signal is a sine signal. Okay. Here it is mentioned also. Reference signal and carrier wave signal. Okay. So here the sine is reference signal and this triangular is carrier signal. Okay.
Yes, ma'am.
So triangular means you can see the difference between these two figures is here triangular is started from 0. Yes or no? And here the some shift is there. The 0 degree is started after some time. Yes or no? So there is some phase shift. But both are triangular. Yes or no?
yes ma'am
So here that will given to a comparator. This is nothing but a comparator. Okay. So this is nothing but a comparator. So whenever you can, I'm making you understand this one. Operation is same. You can see sinusoidal is this green color and this black one is triangular. Sometimes the triangular wave is more than sinusoidal wave and sometimes it is less than triangular sine wave. Yes or no? Triangular is less than sine wave. Yes or no?
Yes, ma'am.
So here sine is given to the plus signal, plus terminal of the comparator. So whenever sine wave will be more than your triangular wave, a pulse will be generated. Okay? बुझिए no बुझिए. So you can see this here this area is where the sine wave is more than the triangular wave. Yes or no? From this point to this point, dotted line. Sine wave is more or triangular wave is more?
sine wave is more
Sine wave.
Sine wave is more. So I will get one get pulse. Another thing you can see here, again sine wave is more than your triangular wave. So you are getting another get pulse. But this get pulse width is not same. Is it same? Is it
No,
same?
ma'am.
This width is more. So according to this time duration, this width will be different. Okay. Similarly for all the cases, here also same, only the difference is here triangular wave, the starting point is 0. Okay. But here also whenever sine wave is more than triangular wave, we are getting a pulse. Yes or no?
मैम मैंने फेज शिफ्ट हैला माने अनइक्वल विथ एसबो
सेमती किछि मान नै तू जदि फ्रीक्वेंसी ट्रायंगुलर आउ टिके बढ़े देबु आउरी मे बी आउरी अधिक पल्स भी आसी पारे. अच्छा देख एठी मु जेति कि नेछि ट्रायंगुलर आउ टिके फ्रीक्वेंसी बढ़े देबी तो आउरी सरो सरो गेट पल्स आसीबो ना आसीबोनी रे ना आउरी स्मॉल गेट पल्सेस आई विल गेट. यस और नो? इफ बिकॉज़ अरे हो ना नहीं, लेट carrier wave signal the frequency, triangular wave frequency I will change. What will happen? I will get more get pulses. Yes or no?
yes ma'am
Yes,
So what is the use of this PWM? So whenever I will get more get pulses, I will get more, the output will be, in the output waveform will be exist more for more time. Yes or no? So in that, what is the disadvantage between the basic method where you are using not direct pulse generator and this PWM is, if you are using PWM, the harmonic content will be less. Okay, that's why we are going for PWM method. Understood? So, ଏଠି भी unequal equal ଆସିପାରେ ସେମିତି କିଛି ନାହିଁ. Only the number of pulses will be more here. Here the number of pulses will be less. कि ଗୋଟେ କହୁଥିଲା same width different width. For this case it is looking like that, this like same width. But here if I will increase the frequency, maybe I can get unequal width of pulses. Understood?
Yes, ma'am.
But here the number of pulse, whenever it will start from 0, the number of pulse will be less. And whenever it will start from 0 point will be after some delay, then the number of pulses will be more. There is a calculation of this also. Okay, that you will study in theory. Okay, according to the magnitude, you can calculate the number of pulses. Magnitude and frequency of the signal, you can calculate the number of pulses in PWM. Okay, so whenever you will see in that case, also I have one slide, but that is theory part. Ma'am will teach you that, don't worry. Single PWM. So type कोउथिला तुमको गेले थिला बेली बहुत टाइप दो. The expression you can see, and I move the details for only, but you can see only odd harmonics are present for single PWM. Similarly, for different, this is multiple PWM, this is sinusoidal PWM. Okay, so you can see one case is when number of pulses per half cycle, one case 1 is there, we are calculating the number of pulses. Similarly, one case 2 there, another pulses. So case 1, case 2, you can see number of pulses is 3 for one case, that is our first figure, and 2 for the second figure. Yes or no? So you will study that in details. So by depending upon the frequency of the carrier wave and the reference wave, okay, it is varying. Is it clear?
Yes, ma'am.
So number of pulses will be different. Width will not be different. Okay, pulses, number of pulses you will get, that will be different. Okay, sorry. So here, so in the diagram, if you see, so you can see whenever this sine wave will be compared with your triangular wave, you will get a pulse. Yes or no? And that width is not same. Somewhere it will be more, somewhere it will be less. Yes or no? So, but you know, whenever G1 and G2 is on, at that time G3 and G4 will be off. Yes or no?
Yes, ma'am.
And whenever G3 and G4 will be on, at that time G1, G2 will be off. Yes or no?
Yes, ma'am.
So after that comparator, one second. Okay. If we draw the gate pulse, if I'll draw the gate pulse, okay, I'm writing G1, G2 means first one I'm writing, okay. So after the that comparator, let I am getting this type of output. Okay. That I am getting this output. So whenever this will be on, for G2, what the output will be 0 or not? Yes or no? Habani re? I'm drawing like that axis, don't worry. So this is G1, G2. So how G3, G4 will look like? Huh? Kim dekha jibo re? If it is on, then 3, 4 is off.
Off.
And if it is off, then at that time G3, G4 will be on. Then it is again off, again on, yes or no? Again off, like this. Habani? Na kaun karke kaha doubt hochi?
No, ma'am, no.
If this is the comparator output, if this is the output of the comparator, how I will get this G3, G4 waveform? I know this G3, G4 is related to G1, G2. Yes or no? So the comparator output is G1, G2. Okay, let G1, G2. Yes or no? So how to calculate G3, G4 from G1 and G2? କେମିତି ହବ ଲଜିକ୍ ଗୋଟେ କୁହ କ୍ୱିକ୍ ଅଞ୍ଜଳି ପ୍ରିୟଦର୍ଶିନୀ କହ କଣ ହବ କ୍ୱେଶ୍ଚିନ୍ ବୁଝା ହେଲାନି ମୁଁ କହୁଛି G3 and G4 is related to G1 or G2 or not?
Yes, ma'am.
Yes, so I know G1 and G2 because that is the output of the comparator. Yes or no?
Yes,
That
ma'am.
is the output of this comparator is G1, G2. This get pulse is for G1 and G2. Then how to calculate G3 and G4? I'm asking that because in your diagram you have 4 switches, na? You have 4 switches: G1, G2, G3, G4. Not of G1, G2. So you will get. So if the comparator output is this, so you will use one NOT gate after the output of the comparator. So you will get this G3 and G4. Yes or no?
Yes, ma'am.
Samaste bujhila? So in the slide also, slide also you can see one, is it clear, visible? This waveform diagram is clearly visible to all. Now is it visible? You can see one output is of the comparator is given to S1, S4, but another is given with a NOT gate. Yes or no?
Yes, ma'am.
Okay. So then I have written the advantage or some points about PWM. Now is it clear PWM about PWM? Are you clear? Quick, or any doubt? अरे कुह ना ଥିଲେ ତ ନା ତ କହିବ ନା କିଛି ନାହିଁ
मैम
କୁହ ଜାଣିବ ଜଣେ କୁହ
मैम जो आउटपुट माने गेट 1 और गेट 2 गोटे माने जो पल्स टा रोचे गेट 3 गेट 4 जो पल्स है तो वेट तो डिफरेंट रोचे सो आउटपुट रो जो वोल्टेज आसीबो माने जो वेव माने एसी वोल्टेज तार तो माने सेम रहइबोनी
ରହିବନି ମୁଁ ତ କହିଲି ରହିବ ବୋଲି ସେ जो वेवफॉर्म टा ମୁଁ ଡ୍ର କରିଥିଲି ସେଟା जो मैनुअली तमे जो तो गेट पल्स ପାଇଁ मैनुअली तो दउथुलु जो गेट पल्स 0 to 180 डिग्री हैला सेतरे सेमते आसीबो एबे केमते आसीबो एबे भी तमरो आउटपुट एमती ही आसीबो पल्स भलिया हैला मुझे
मैम हमरा आउटपुट रो पीक वैल्यू टा सॉर्ट बाय सेम रहइबो
हां इट विल वेरी फ्रॉम VD to -VD ओके
यस मैम
अच्छा कोनो दिला कल के डाउट छ सो एक्चुअली यू हैव टू टाइप्स
G3 G4 टा होता बुझे देबे
So सुनो G1 G2 और G3 G4 तो गैप कितने मतलब फर्स्ट को अरे G1 G2 तो समान जान पर चु so what the gap between 1 2 and 3 4 what is the gap between 1 2 and 3 4 if this is on this is off if this is on then this is off yes or no
Yes, ma'am.
so what is the gap between on and off अरे गोटे 0 हेले गोटे 1 गोटे 1 हेले गोटे 0 so which gate you will use if I will on that is 1 let switching on means 1 off means 0 so if G1 is on G3 is off if G3
ma'am.
is off if G3 is off then G1 is on so 1 0 means 1 1 1 yes or no
Yes, ma'am.
so which gate you will use not gate you will use na अरे नॉट गेट रो इनपुट जे 0 थिबो आउटपुट 1 हबो 1 थिले 0 हबो नो डाउट अछि अंकित
No.
तो आउ माने
किसी डाउट नहीं है सब कुछ नहीं
मु बुझी पने तो आउ जदी कोन जानियो चाहू मते कह गोटे
मैम से नॉट गेट तक जल्दी यूज होला सेटा टिके डाउट पर
एबे भी डाउट अछि अच्छा मु कोजे जीवन जितु इतला ऑन होतला माने जितु तू नॉर्मल गेट पर से तू कोजले में क्लास पढाले निजे करबो एटा ऑन एटा ऑफ ओके सो एटा कहार गेट पल्स लेट G1 और G2 ओके G1 और G2 G3 और G4 गेट पल्स केमते हबो टे कहलु हां अंकित
आगे जीरो होगा फिर सेकंड पोर्शन है 1
एटी 0 हबो कारण G1 G2 इतला ऑन होची तू G3 G4 ऑन करबो की G3 G4 पे में तो अलगा उल्टा आउटपुट पाइबो नेगेटिव आउटपुट पाइबो माने नहीं तो G1 G2 on means G3 G2 G4 should be off yes or no so एठी हबो 0
यस मैम
एठी हबो 1 तो जदि एई पल्स रते मु देइची तू याद हेरु एटा केमती काढिबो गोटे नॉट गेट लगे दिले बाहरिबो नॉट गेट माने आउट ऑफ फेज माने गोटे ऑन हेला आरटा ऑफ बुझी पड़लो गोटे 1 हेला आरटा 0 तो नॉट गेट लगेबो ना को गेट लगेबो
मैम बुझिली
एठी मु सिंगल पूरा गोटे पल्स पूरा 180 डिग्री पे नहीं जाइची मतलब पीडब्ल्यू में यूज करछो ए 180 डिग्री तुम मल्टीपल पल्सेस यू आर गेटिंग on off like this in this single pulse and if manually you will give the gate pulse you will get a single pulse for 180 degree duration but here multiple mane what inside that duration you will have more than one number of pulses understood
यस मैम
actually you have two types of design in this PWM inverter also you have one is unipolar PWM inverter okay another is bipolar PWM okay understood you have two types so you will design these two okay in these two you will design and you will see the difference okay so the method I have shown you that is bipolar just now one arrangement I have shown you this one yes or no this one or in this one whenever one set of switches are getting one pulse and other are getting after the not get the output they are getting yes or no so that is a bipolar scheme this is a bipolar scheme okay I'll say what is the difference between unipolar and bipolar but this scheme is bipolar okay is it clear but what is the unipolar scheme the diagram circuit diagram will be same okay in the unipolar प्रत्यदिश तो एबे जॉइन करछि प्रत्यदिश तो
यस मैम
एबे के जॉइन करलु
मैडम मुझे इंटरनेट कनेक्टिविटी के प्रॉब्लम दउतला मझरे तो मैडम जॉइन
ट्राए करथले हो नथला से देख आ तो फोन 2-3 थर रिस्टार्ट मारला पर जाई होची
ସତ କହୁଛୁ ନା ମିଛ କହୁଛୁ?
ମୁଁ କାଇଁ ମିଛ କହି ମ୍ୟାଡାମ ମତେ
ତମମାନେ ହିଁ ମିଛ କହିବ, କି ମିଛ କହିବ ରେ? କାହିଁକି ମିଛ କହିବ ମୁଁ ଜାଣିନି, ମାନେ କାହିଁକି ମିଛ କହିବ?
ମ୍ୟାଡାମ ରିଜନ ତ କିଛି ନାହିଁ ମ୍ୟାମ, ମୁଁ ସତରେ ସେ ପ୍ରୋବ୍ଲେମ ହେଲା ବୋଲି ମ୍ୟାଡାମ ଲେଟ ରେ ଜଏନ କଲି, ନହେଲେ ମ୍ୟାମ ମୁଁ ଠିକ ଟାଇମ ରେ ଜଏନ କରିନଥିଲି।
ଆରଥର କତବେ ତୁ ଜଏନ କରିଥିଲୁ ବୋଧେ ଲେଟ ରେ?
ନା ଆରଥର ଠିକ ଟାଇମ ରେ କରିଥିଲି, ଭୁଲ ସେ କଟି ଯାଇଥିଲି, ଭୁଲ ସେ ଡିସକନେକ୍ଟ ହେଇଯାଇଥିଲି ମ୍ୟାଡାମ, ଲାଷ୍ଟ ଟାଇମ ଭୁଲ ସେ ଡିସକନେକ୍ଟ ହେଇଥିଲି।
ମୁଁ ସେ ତୋ ସହିତ ହିଁ କାହିଁ ବାରମ୍ବାର ରିପିଟ ହଉଛି ପ୍ରୋବ୍ଲେମ ଟା, ମୁଁ ସେଇଟା ପଚାରୁଛି।
ନା ଜାଣିନି ମ୍ୟାଡାମ, ଟିକେ ଦେଖୁ ସେ
କାହିଁକି ତୋ ସହିତ? ତୁ ଯେମିତି କହିଲୁ କାହିଁକି ଲେଟ୍ କରି, ମୁଁ କାହିଁକି ତୋ ସହିତ ହିଁ
ମାନେ ଲାଷ୍ଟ 2 week ହେଲେ ଅସୁବିଧା ହଉଛି ମ୍ୟାଡାମ ଟିକେ।
ସେଥିପାଇଁ ମତେ ଏକ୍ସଟ୍ରା ତୁ କଣ କରିକି ଦେଖେଇବୁ?
ଏକ୍ସଟ୍ରା ମ୍ୟାଡାମ
ତୁ ଲେଟ୍ ରେ ଜଏନ କରୁଛୁ ବୋଲି ତୁ କଣ ମତେ ମାନେ ତୁ ମୋଟ ମାନ 1 ଘଣ୍ଟା ମୁଁ ପଢେଇଲେଣି, ତୁ 1 ଘଣ୍ଟା ପରେ ଜଏନ କରୁଛୁ, ତୁ ମତେ ଏକ୍ସଟ୍ରା କଣ ଆଉଟପୁଟ ଦେଖେଇବୁ କହ? ଗିଭ୍ ଆଣ୍ଡ ଟେକ୍ ରିଲେସନସିପ ଆଉ କଣ? ମତେ କିଛି ଦେଖେଇବୁ ଯଦି ତାହେଲେ ତୁ ମତେ କିଛି ଏକ୍ସଟ୍ରା ଆଉଟପୁଟ ଦେଖେଇବୁ ଯଦି, ତାହେଲେ ତତେ ମୁଁ 1 hour ର ଛାଡ କରିବି, ନହେଲେ କାହିଁ ତତେ ମୁଁ ଛାଡ କରିବି? ହଁ କହ। ଆଜିକାଲି କିଛି ବି ରିଲେସନସିପ ତ ୱିଦାଉଟ୍ ଗିଭ୍ ଆଣ୍ଡ ଟେକ୍ ପସିବଲ ନୁହେଁ। ତ ମତେ କଣ ତା ଏକ୍ସଚେଞ୍ଜ ରେ ମିଳିବ? ତତେ ମୁଁ ଆଲାଉ କରିବୁ 1 hour ପରେ, ମତେ ତାର ଏକ୍ସଚେଞ୍ଜ ରେ କଣ ମିଳିବ?
ଆପଣ ଯୋଉ ଟାସ୍କ ଦେବେ ଟିକେ ଜଲ୍ଦି ସବମିଟ କରିଦେବି।
ମତେ ଏକ୍ସଟ୍ରା କରିକି ଦେଖିବୁ, କ୍ଲାସରେ ମ୍ୟାଡାମ ଯୋଉ ପଢଉଛନ୍ତି ଥିଓରି, ଯୋଉଟା କି ଆମେ ସବୁ ତ ଲ୍ୟାବରେ କରୁନେ, ଏକ୍ସଟ୍ରା ଗୋଟେ ଡାଇଗ୍ରାମ କରି, ଯୋଉଟା ଆମର ଲ୍ୟାବରେ ହେଇନି କିନ୍ତୁ ଥିଓରିରେ ପଢିଛୁ, ରେକ୍ଟିଫାୟର କରିକି ଦେଖିବୁ। ବର୍ତ୍ତମାନ ରେକ୍ଟିଫାୟର ଚାଲିଛି ତମର, ହଁ ନା ନାଇଁ?
Yes, yes, ma'am.
ଠିକ ଅଛି। Achha, bipolar you have understood? Just now I have discussed bipolar. Yes or no? So, what will be the unipolar scheme? This is the unipolar scheme. Okay. Is it clearly visible? Is it visible, right?
No, ma'am.
Yes.
I'm trying to. Now is it visible? I will tell you what is the just. You can see this is a comparator. Can you see this comparator? Not gate. Here not gate. A comparator. Is this visible?
Yes, ma'am.
So here you can see you have 2 references. Yes or no? You have 2 references but only 1 carrier. Okay? And here how many gate pulses you are generating? 4. Before only 2, because for S1 and S3 1 and opposite भी से थी कौन S1 जहाँ भी ना थी ला, हो ना नहीं? S1 और S2 पे समान, S3 और S4 पे समान. So here, in case of bipolar, actually you are generating 2 pulses. One is for S1 and S2, another is for S3 and S4. So instead of that, in the unipolar scheme, you will generate 4 gate pulses. You can see 1 for switch 1, 1 for switch 2, 1 for switch 3, and 1 is switch 4. Okay? Yes or no? What is the gap between this switch 1 and switch 4? It is again 180 degree or not? Because when S1 is on, S4 is off. Yes or no? On na re? S1 on rahile, S4 off rochi na? And when S2 is on, S3 is off. So S1, what is the pulse for S1? If you will connect and not get, you will get S4. Yes or no? And whatever output for S3, if you connect and not get, you will get the output for S2. Yes or no?
Yes, ma'am.
So,
मैम गोटे डाउट अछि मैम बाइपोलर स्कीम रे हमें S1 और S2 एकाठी नोतले बट एठी हमें ब्रांच वाइज देखिबा पूर्ण सेपरेटली
but तुम देखिबो मन तमे से माने बेसिक फंडामेंटल चेंज होनी. S1 on means S2 will be off, because तुम जानचो if in a single arm if both will be on at a time, then this branch will be short circuited, this arm will be shorted, source will be shorted, you will not get any output. Yes or no? So that is your aim. So whenever S1 will be on, S4 will be off. So the fundamental is same. Basic, whatever basic for bipolar, here the basic is same. Only you are giving a different type of comparator input is different. Instead of using one carrier, here you are using two carrier. Okay.
Ma'am, one KVL for S1, S4, another one for S2, S3.
One KVL na कौन KVL?
Ma'am, एइला आपण कहउथुन दीटा KVL यूज होबो.
ना सेतेले S1 S2 at a time on होची सेतेले एठी कोन हबो S1 S2 at a time on हबो केतेले S1 थिबो S2 भी on हेइ नथिबो because all the pulses are different. Yes or no? So there will be some period for unipolar, I am saying. For unipolar, for whatever operation I have till now I have taught, that is for bipolar, not for unipolar. Yes or no? For bipolar, the current flow I have shown, that is for bipolar. Unipolar पे तो कोई नहीं मो, है चीरे?
No, ma'am.
So for bipolar S1 and S2 is on at a time, na? This switch and this switch is on at a time for bipolar. But for unipolar, there will be some time whenever S1 will be on, but S2 will not be on. So there will be no current flow. It will wait. Whenever S1, S2 will be on at a time, then only current will flow. But this situation will not happen in case of bipolar. S1 on means S2 on. But unipolar S1 may on, but S2 off. S2 may on, S1 will be off. This situation will arise in unipolar. Okay?
Yes, ma'am.
Okay, so here you can see one is VR. This one is VR. Reference. So if you are giving, let VR is sine wave, previously we have given sine wave, yes or no? If you have given sine wave for VR, so what will be minus VR? Minus VR कौन हो रहे? That means it will be like this, yes or no?
Yes, ma'am.
That means how much phase shift? 180 degree phase shift? Yes or no? Are 180 degree phase shift? What is the VR of minus V with the phase shift kete? 180 degree?
Yes, ma'am.
Carrier is same. Okay. Carrier is same triangular. Okay. Same triangular. So एठी भी triangular comparison होगा. Okay. एठी भी triangular comparison होगा. But you will get different output na, because your carrier signal is different. Sorry, your reference signal is different na. So you will get output different. Here output and here output. It will be different or same? Different habo na same habo?
And
Ma'am,
different.
different.
Different habo? Okay. So if this will be different, after the NOT gate this will be different than this one, yes or no? So S2 or S4 output, eta alga jidi, to after NOT gate also obviously this will be different, yes or no? So
Yes.
you remember this comparator, this will be the design for of the comparator for unipolar. Bipolar is simple, okay? So let's do it first, and there you can see the difference in output, okay? Okay, so how the unipolar output is looking like and how the bipolar output is looking like, that you will check. And here you will do the FFT analysis, because you can see the output is not purely sinusoidal, because output is AC or not? Output is AC, but you are not getting a pure sine wave. Are you getting a pure sine wave in the output? No. So there will be a lot of harmonics in the output waveform. Yes or no? V0. So you will do the FFT analysis of V0. Understood? And which value you will measure? RMS value or average value? Theoretical calculation, right?
I'm average.
No. Why average? In AC, average is 0, na? Output is AC. So will you calculate the average? কি কইলা বিশ্ব?
Sorry, ma'am.
কোন কাড়িব? RMS rectifier output DC thila. That's why we have calculated average. Again, we also have calculated RMS because the output is not pure DC. Some harmonics are there. But here, the output is AC. So output AC means positive half, negative half will be get cancelled. So average if you will measure it will be 0. Yes or no?
Yes, ma'am.
Others, are you getting me what I'm saying?
Yes, ma'am.
So you will measure the average value. Yes or no? Sorry, RMS value. Okay. Now start the connection quickly. Quickly. Here you can take MOSFET also. MOSFET if you want to take so everyone take MOSFET. Later you can use with do with IGBT. ସମସ୍ତଙ୍କର ଆଉଟପୁଟ୍ ସମାନ ଆସିବାକୁ ଚାହୁଁଛି ତ ଆଇ ଏମ୍ ସେଇଂ ଏଭ୍ରିୱାନ୍ ୟୁଜ୍ ମସ୍ଫେଟ୍ ଓକେ So how many MOSFETs I want?
4 MOSFETs.
Then supply voltage. Elements, source, voltage, DC. Okay. Output is input is DC, na?
Yes,
Then
ma'am.
with R load you will do. So here also I can place. Yes or no? Here also I can place, or according to diagram, you will place here. Yes or no? Then এখন দরকার ছিল get pulse is not required, we will generate that from PWM method. Yes or no?
Capacitor ওটা
And capacitor lagan direct constant voltage source we are using. Okay, no need to use the capacitor.
yes ma'am
Capacitor is connected in parallel only to remove the filter out the harmonics. If you direct किसी छोटे source through दो तो DC, then you will use a capacitor. Here you are using direct DC, no need to use the capacitor. Then what else? Probe voltage for, because you want to measure the output voltage value. Yes or no? Now connect.
ammeter use କରିବନି
ନା ଦରକାର ନାହିଁ ଆମିଟର ତ ଡିଫରେଣ୍ଟ ହବ ତମର କରେଣ୍ଟ ତ ଲୋଡ ଅନୁସାରେ you can check that is your work. If you want to check, you can use the different load and check the current waveform. Theory ରେ ପଢିବ ଯେ current waveform ଅଲଗା ଅଲଗା book ରେ ଦେଇଛି ବି ଦେଖିବ. So if you want to check, you can check that. Okay, diagram is there, later you will check. Okay. 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 ଆଉ ଏଠି ନା ତମେ ଡାଇରେକ୍ଟ ଗେଟ୍ ପଲ୍ସ କନେକ୍ଟ କରିପାରିବନି, so you have to use a on off switch, normal on off switch. ଏଠି ଦେଖ after the pulse generator you have a on off switch. So the comparator output will be given to this switches through a on off switch. Okay. So to every switch you connect that. Clear? Acha. Okay, clear? Is it clear? Complete?
Yes, ma'am.
Now we'll design that comparator part. Yes or no? So here you can see there is a comparator. This side in the right side. Did you get the comparator?
Yes,
First we are designing the bipolar scheme, okay? Bipolar PWM scheme we are designing. Hala? So, how many references are required? One? Yes or no? And that is to sine. So here there is a sinusoidal voltage source. Yes or no? And in the side there is a triangular wave voltage source. Take that one. Take a ground. Okay. Another thing you require NOT gate. Yes or no? So NOT gate is here. Yes or no? This output is only comparator output. This is the output after NOT gate. So this output will be given to which and which switch? This first one.
S1, S2.
This one, yes or no? ଏତେ କିଛି ନା ଦେଇନି ଜାଣିପାରୁଛ ଏଇ ଦୁଇଟା କର୍ଣ୍ଣର yes or no? And this output after the NOT gate it will be given to this one as well as this one, yes or no? अच्छा but R कितना नंबर? Let's take R equal to 10. Okay. Voltage you can let I'm taking 100. मतलब 100 अच्छे 100 ही नोचे. Okay. जे सर्किट करी परलो ना माने बे वैल्यू सेट करिवो ना म पे करिवे.
मैम टिकट के गोटे मिनट
मैम कंपैरेटर तो डायरेक्ट फीड करी हबो बट ऑन
ना
ऑफ
कंपैरेटर डायरेक्ट रे फीड करले लागिबन. देख लॉजिक देख. लो सर्किट हे जाउची हैला. लो पावर सर्किट एपटा हे जाउची सेपटा हाई पावर सर्किट हैला. थ्रू ए स्विच यू हैव टू गिव किछ आइसोलेशन रखी दे हबो हबनी कनेक्शन हेले भी रन हबनी हैला.
ओके मैम
बट मैटलैब रे तमे
नॉट गेट टा को जगह अछि
नॉट गेट टा ए साइड रे छवा कंपैरेटर रो दीटा गोटे पर छाडी देख. जेमति मैटलैब रे करिवो डायरेक्टली दे परिवो सेंति किछ नै तो पीसी रे डायरेक्ट दे होले ହେଲା କଲରେ
Yes, ma'am.
Yes, ma'am.
the 100 দিল সোর্স রেজিস্ট্যান্স দিল 10 তোর ক্যারিয়ার ওয়েভକୁ যাও সাইনোসয়েডাল ক্যারিয়ার ওয়েভটা করছে সাইন সরি রেফারেন্স ওয়েভ টেক 0.8 magnitude is 0.8 okay and 50 hertz ହେଲା okay ବୁଝିଲ କଲ
Yes, ma'am.
ମ୍ୟାମ୍ କ୍ୟାରିୟର ୱେଭ୍ କେତେ?
ରେଫରେନ୍ସଟା କରୁଛି କ୍ୟାରିୟରଟା କରୁଛି ଟ୍ରାଙ୍ଗୁଲାରକୁ କ୍ଲିକ୍ କର ପିକ୍ ଟୁ ପିକ୍ ହେଉଛି 0.2 ମିନ୍ସ ମାନେ କ'ଣ ହବ ରେ ଭ୍ୟାରି କେମିତି କରିବ ମାନେ ମାଇନସ୍ ଦିଶେ ଅଫସେଟ୍ କେତେ -1 ମାନେ -1 ରୁ ଭ୍ୟାରି କରିବ +1 କୁ ଯିବ ପିକ୍ ଟୁ ପିକ୍ ଦେଖୁଛ ଗୋଟେ 2 ଲେଖା ହେଇଛି
Yes, ma'am.
2 ହିଁ ରହୁ କାହିଁକିନା ତମର ମ୍ୟାଗ୍ନିଟ୍ୟୁଡ୍ କେତେ ବାହାର କରିବ -1 ରୁ 1 ହେଲା ଆଉ ସାଇନ୍ ୱେଭ୍ ତମେ କେତେ ତାର ଟିକେ କମ୍ ନେଇଛ 0.8 ନେଇଛ yes or no so keep it as 2 okay frequency high frequency let I am taking 5000 if I am taking you can take 500 no worry any frequency but that should be more than 50 yes or no okay so I am taking 5000 ଯାହା ଅଛି ସେୟା ରଖ କିଛି ଚେଞ୍ଜ ଏତେ ତାହେଲେ କରିବାର ନାହିଁ ଓକେ
Yes, ma'am.
now simulate let run it for କେତେ ସେକେଣ୍ଡ ପାଇଁ ରନ୍ କରିବ ରେ 1 ସେକେଣ୍ଡ ରନ୍ କରିବା ଦେଖିବା କ'ଣ ଆସୁଛି
Ma'am, time के दिले
1 सेकेंड ही रहता 1000 दे दिली रे मैं तो दीजिए वन थाउजेंड कौन देखो रे अच्छा मिली सेकेंड देखो चलो मिली सेकेंड ले चलो कम टाइम पे रन करिया ना टाइम नंबर मन करो 0.1 नलो 0.1 ओके अरे देखा ना अब 1 सेकंड बहुत है पॉइंट 0.1 नहीं कि 0.05 नलो देखिए अब टिके जाना पड़ेगा at least you can zoom it now okay 0.05 okay you can see now the pulses you can see yes or no
Yes, ma'am.
so later I am zooming it from 0.04 to 0.05 okay yes or no एक पर जो pulse width is not everywhere same yes or no
Yes, ma'am.
so this is your what bipolar change कर दे ना आटा change करनी है डाउच भी 0 this is bipolar okay तो यार तो मैं हमें करी FFT analysis first we will design the unipolar scheme then we will do the FFT analysis of both so that we can study the difference yes or no
मैम आउ थोड़ी वैल्यूज गुड़ा कोई भी की
कार वैल्यू दरकार तबे
मैम वोल्टेज सोर्स जो अच्छी
100
तो साइनोसॉइडल
0.8 ट्रायंगुलर किसी चेंज करनी साइन रो खाली 0.8 नीच You can also take the peak amplitude which is less than point, that is 0.6 or 0.7, but always take then less than 1, because rectangular you have taken the peak amplitude +1 to -1. Yes or no? Okay. Clear?
ମୋର ଟିକେ ଦେଖୁନି ମ୍ୟାମ୍, ସେ କହୁଛି ଭ୍ୟାଲ୍ୟୁ ଗୁଡ଼ା ଫ୍ଲୋଟିଂ ଦେଖଉଛି ସ୍ୱିଚେସ୍ ଗୁଡ଼ାର ଯୋଉଟା ମସ୍ଫେଟ୍ ସହିତ ଲାଗିଛି।
So ଲଗେଇଛି switch,
ହଁ ମ୍ୟାମ୍, ସେଇଠି ସେ ମ୍ୟାମ୍ ସେ ଏରର ଏଲିମେଣ୍ଟ ଦେଖଉଛି ସେଇ ସ୍ୱିଚଟା, ମ୍ୟାମ୍ ମସ୍ଫେଟ୍ ନୁହଁ ମ୍ୟାମ୍, ସେ ଯୋଉ ଅନ୍ ଅଫ୍ ସ୍ୱିଚଟା ସେଇଟା ଦେଖେଇ କହୁଛି ଭ୍ୟାଲ୍ୟୁଜ୍ ଆର୍ ଫ୍ଲୋଟିଂ ଦେଖଉଛି।
ତ ଠିକ ସେ କନେକ୍ଟ ହେଇଛି ତ, ଦେଖିଲୁ, ସେୟାର କଲୁ।
ଠିକ୍ ତ ଅଛି, ଗୋଟେ ମିନିଟ୍ ମ୍ୟାମ୍ ସେୟାର କରୁଛି।
ରହ ମତେ ଷ୍ଟପ୍ କରିବା ପାଇଁ। ଅନ୍ୟମାନେ ବାଇପୋଲାର ଡିଜାଇନ କରୁଛ? ଗୋଟେ କାମ, ଏଠି ନଟ୍ ଗେଟ୍ ଲଗେଇଛୁ ତ ତୁ, ନା ସୁଇଚ ଟା ଲଗେଇଛୁ ଏଠି? ନଟ୍ ଗେଟ୍ ଲଗେଇନୁ, ଗୋଟେ ସୁଇଚ ଲଗେଇଛୁ, ନଟ୍ ଗେଟ୍ ଲଗା। ଶୁଭୁଛି ମୋ କଥା ତତେ?
ୟେସ୍ ମ୍ୟାମ୍, ସ୍ୱିଚ୍ଟା ଲଗେଇଛି ମ୍ୟାମ୍, ଭୁଲ ସେ ଲାଗିଯାଇଛି।
If you want to see the gate pulse also, you can see. Let I want to plot. Let this is, you are using node voltage. You node voltage, because this is one pulses we are giving to switch 1 and switch 2. Another is this one. Yes or no? होना नहीं रे? This is VG1 and this is VG2. Okay, if you want to see the output of the PWM, so same odd. See, whenever there is blue, there is not red. There is not blue, there is red. Yes or no? Can you see? देखिए उचरे, देखिए उन्हें, हाँ, तुम्हारे प्लॉट कर लो।
मैम जोटी ओवरलैप करछि सेटा साइन वेव पार्टटा,
तो साइन को देखिए चाहूँगी, ठीक अच्छे। टेक अनदर, जोड़ दे उसका नोड वोल्टेज, यूज हियर, अनदर यूज, okay. This one is sine, yes or no? This one is a triangular, or you can see this is your what, carrier BC, and this one is your V reference. होना नहीं? सेम रे प्लॉट करिए, क्लोज दिस, BR BC, देख पाचो जो गोटे एरिया जूम कर दे 0.0 1, 2, 0.015. You can see the triangular now you can see. We have taken very high frequency. If you take 500, you can see it clearly. Okay, I'm changing it. You keep it as 5,000. I'm changing it. Okay, 500 I'm changing. See? Exporture?
Yes, ma'am.
So now in the VG1 I will plot. Okay. See, whenever your sine wave is more, you will get output. Whenever your sine wave will less, the output will be 0. G1. Say Ashton. Next is VG2. Just opposite you can see whenever it is 0, it is 1. Okay. Next is your V0. तो मैंने 5000 रे करो कारण तुम FFT एनालिसिस करिवो तो you take high frequency. The frequency अधिक नबो your harmonics will be less. Okay. For the output, I am showing this, but you can zoom any part and you can show the output for 5000 frequency. Yes or no? You don't change. So is it now clear? Or any doubt in the bipolar?
ଆପଣ V0 ଟା ଆଉଟପୁଟ୍ ଭୋଲ୍ଟେଜ ନେଇଛନ୍ତି ନା?
V0 is output voltage. କଣ ହେଲା କଣ?
ମାନେ ସେଇଟା VG1 ସହିତ ସମାନ ଅଛି କଣ ସେ ଭିତରେ?
ସମାନ ଅଛି ପୁରା?
Yes ma'am, पूरा सेम.
आउटपुट इन एच है समान आस बट V0 एटा ही V0 है सब बड़े समान आस मानने है एपटा 5000 देखले तो 500 5000 रे आछी कि आसना तो है
Yes ma'am.
अच्छा बाइपोलर देखिबा ना सॉरी यूनिपोलर देखिबा ना आई एम जस्ट कॉपिंग दिस ऑल Okay. नम सेम न करन थली कि पूर्वडा तुम ट्रायंगुलर 5000 रे करछो रे
Yes, ma'am.
अच्छा एटा तो बाइपोलर यूनिपोलर कोडाला एटा बाइपोलर this is unipolar so only the change will be in this comparator part yes or no
Yes, ma'am.
only one carrier is required so I am doing it again okay just deleting all don't get confused okay I'm just deleting all the gate circuit part okay so you need two comparators yes or no
Yes, ma'am.
then one sign there are two signs one triangular yes or no
Ma'am, we cannot use one sign signal.
How? Because there is some phase shift, na?
Yes, ma'am. Can use one NOT gate.
देखी हल्ला तो भल कथा
मैम करके देखिले जे किंतु से जो नॉट गेट यूज करला परे जो वेव टा है स्क्वायर वेव पळे आछ माने अपोजिट होचे किंतु स्क्वायर वेव आछे
अच्छा
मैं साइनसॉइडल आसुनी
देखिया हेरा देखिया ताले होता देखि हला
यस मैम
एटा कर दिया हबो ओके सेम
मैम तଳ साइन वेव टा तो नेगेटिव रे लागिबो ना
वैल्यू चेंज करिवे बुझता तो साइड उठा के नेगेटिव लागियो
मैम ट्रायंगुलर वेव तो दीटा से तो माने कनेक्टेड अछि
तो ट्रायंगुलर वेव टा आर भी नेगेटिव लागिला आर भी नेगेटिव लागिला
अच्छा अच्छा
तो देखैतली तुम डायग्राम टा कंप्लीट कर दे यार भी এটা নেগেটিভ আর भी এটা নেগেটিভ এটা উল্টে দিছি কম্পারেটর বুঝিলো মিরর ইমেজ कर দিছি হলা হেতমে কনফিউজ हो छु तो नॉट गेट তারপর দিটা দরকার 1 2
मैम ट्रायंगुलर वेव रो दीपट टर्मिनल दीपट आनी लगेला हबनी
দিটা ট্রায়াঙ্গুলার লগেবু তো
ना मैंने गोटे ट्रायंगुलर रो दीटा टर्मिनल अछि ना ता आरो टर्मिनल टा आनी
না
तो
না
हम
না সেটা গ্রাউন্ড হবো সেটা গ্রাউন্ড কর কিন্তু আরেকটা লগাই দেবো রে ହେଲା ইনপুট দিটাକୁ সমান ଯିବ না দিটা সমান ট্রায়াঙ্গুলার তো এটা গ্রাউন্ড হবো হ্যাঁ
ओके मैम
এইটা উপরକୁ দেলি তো নট গেট ର আউটপুট টা কাହାକୁ ଲାଗିବ এই সুইচ টাକୁ মনে নাই রে ହଁ ନା ନାଇଁ and this one will be given to this one not get output will be given to the below one this one yes or no अब से कौन कौच रे तଳ सोर्स टा उल्टा লাগিব को सोर्स टा उल्टा লাগিব रे minus here that I will make here na don't worry I will change the setting minus here means what 180 degree phase shift na shift is 180 degree na so I will make that in the setting okay Abhishek how I will make that I will see here so it is change karo sorry कौन दिला एटा ने 0.8 जा रखले पेपर सर रखो 0.8 50 थिला ना 50 कोन ट्रायंगुलर कोन रखतिलो ट्रायंगुलर जा थिला सर रखो 5000.52 -1 चेंज करनी एटा चेंज करो एटा हो माइनस भी है तो এটা উপরে নিছিল 0.8 আর ম্যাগনিটিউড 0.8 সেম ম্যাগনিটিউড 50 হার্টজ ওকে নাও ফেজ অ্যাঙ্গেল ইউ ক্যান সি সো কেতে টিকে দেবো?
180
180 degrees.
দে 180 okay, so you can see the output. This is my V rectangular. This is VR. No? This is VR1 second reference, and this is the BC carrier.
मैम ट्रायंगुलर वेव है सब सेम रहेगा एज यूजुअल.
आउटपुट उल्टा आसुची ना आसुनी रे आगुड एमती आसुतला आउटपुट बीजे एमती आसुतला रे हाँ
नहीं मैम
अच्छा एक माइनस भी देखिए ना माइनस भी देखो चलो और VR1 ना V minus VR is our VR1 okay see 0 रे ऊपर को this is minus VR or not this is one output
मैम सिमुलेशन टाइम केते देबो?
0.5 needs 0.05 this is one output huh? Another is this is for bipolar. That is for unipolar no? Bipolar make it 5000 and around. See the difference?
मैम टिके यूनिपोलर सर्किट टा आउथरे देखेबे.
देखो
Excuse me, ma'am.
हाँ रे कह किए रखला
No, actually ଆପଣ ଆବାଜ
हेलो कि कौन कौच रे हेलो प्रसन्नजीत
यस मैम.
अच्छा मो बस शुभुस मन को
आगे मैम.
किए गोटे कौन कहला किए कहला रे सरला
आगे मैम.
ମୁଁ ଅପେକ୍ଷା କରୁଛି ସରିଲେ ମୋ ସେ ଆଉଟପୁଟ୍ ଆସିଲା
यस मैम.
so it is you can see the peak voltage you have taken sorry source voltage you have taken 100 so in bipolar it is moving minus 100 to 100 yes or no here Here also minus 100 to 100, but you can see the gap. One positive, like at a time it is some pulses for positive pulses, then negative pulses. Then positive pulses, then negative pulses. But if you look at the bipolar scheme, positive, then negative, positive, negative. In each half there is positive, negative. But here, parallel output. अच्छा, it तो अच्छी output. Here you can see only positive output for half period. 0.01 second means what? 180 degree? Yes or no? Next 180 degree is negative. Right, sign भाई देखा जो देखा जाओ नहीं मत को. ये तो मैं सब pick करने draw करीबो. Looking like a sign or not? One positive half, one negative half. Then positive half, then negative half. Yes or no?
Yes, ma'am.
So for both the output voltage, you will do the harmonic analysis. Okay. Let's do the harmonic analysis. अच्छा ये हमको रिमूव करना पड़ेगा ना. अच्छा रन करते हैं. Only V0 you keep it in the waveform, in the plot window. Okay. Now do the FFT analysis. खाली V0 करे जो ना. कितने नहीं थी रे कैरियर फ्रीक्वेंसी? 5000? कितने लो?
5000.
कोड गुड आशु देख लो. 2FC. Then 4FC. Then 6. अरे होना नहीं. 5 into 2, 10,
Yes, ma'am.
20, 30.
Ma'am, बुझा पड़ानी कौन कहले?
अरे this is your fundamental now. अरे how this is we are doing FFT analysis. Yes or no?
Yes, ma'am.
And 5000 you have taken frequency of what? Carrier?
Yes,
Carrier 5000 frequency is 5000 FC. So harmonics are present at in the V0 waveform. 10,000. You can see at 10,000 frequency is 10,000 hertz here. Then 20,000. So that means if F is 5,000, so it is F. It is what? 2F. It is 4F. It is what? 6F. Yes or no? 8F. Like this. Yes or no?
Yes, ma'am.
So now do the FFT analysis of bipolar. This is for unipolar. Yes or no? Do the FFT analysis for bipolar. Only V0. Keep the V0 output and do the FFT analysis. You can see some more harmonics are present here. Yes or no? This is here also you have taken 5,000 carrier wave. नहीं थी ना नहीं. FC कितने थी? 5,000.
Yes, ma'am.
Yes, ma'am.
So you can see here also at 2F. F माने मैं कोच FC. Okay. 2F, 4F. See it is there also. You can see plus 1 at the half. Has been 2F plus 1 is present. 2F plus 1, 2F minus 1. এটা कितने 5,000 হবে না হবে রে?
Yes, ma'am.
So here also the even numbers are also present. Yes or no? होना नहीं रे? Yes or no? Hello.
Yes, ma'am.
That means here F at F, 2F, 3F, 4F, 5F सबुठी अच्छी होना नहीं?
Yes, ma'am.
कहार फिल्टर डिजाइन इजी हबो? यूनिपोलर ना बाइपोलर? कहार फिल्टर डिजाइन इजी हबो? Now you can see the difference in FFT. In one waveform, only even harmonics are present. In one harmonics, all the harmonics are present, including fundamental with all the harmonics, means odd and even both. Yes or no? So in the inference, I want to see in every one of you in the record, you'll write these are the harmonics, and you'll search that in which scheme, in unipolar scheme or in bipolar scheme, the filter design will be easier. Okay, you will write this. You'll search it and you'll write this. That is your task. Okay? Asum Kordeli, can you write this?
Yes, ma'am.
Okay? ଆଉ କ'ଣ ଡାଉଟ୍ ଅଛି? ଏତିକି ହିଁ ଥିଲା। ଏଥିରେ ଆଉ କିଛି ମେଜର କରିବାର ନାହିଁ, ଏଫେକ୍ଟିଭ ଥିଲା ଆନାଲିସିସ୍ କରିବ। ହେଲା? नो डाउट कि यदि किसी कौन फेस कर प्रॉब्लम स्क्रीन शेयर करो और एल्स शो द आउटपुट।
मैम मैम यूनिपोलर ये प्रॉब्लम हो जो आउटपुट रे
शेयर का कौन प्रॉब्लम होची?
हम से ही आउटपुट बाहर नहीं
स्क्रीन शेयर करनो करो। सौभाग्य
यस मैम शेयर करिए